Today, I'm going to go through what if you come to Isaac Sim and you have a robot that you want to simulate. Um, oh, hello. Yeah, what if you, so this is like you're coming to Isaac Sim, you have some robot you're interested in simulating that's not already supported in Isaac Sim. What do you do? How do you get started? Uh, the tools for this are constantly evolving, and with the last release, things are getting like pretty reasonable, pretty workable. You have some good options, so I'm going to go through those. So to do this, I'm going to, it's easiest if I just share my entire screen. Um, and what I'm going to show, just hiding that, is I have a robot to add called TechMan. I actually have to add this into Isaac Sim so that we're going to support it, but I'm going to do that on stream so that you guys see what I do with a somewhat unknown robot. So someone gave me this folder, TechMan, and in it is a URDF of this TechMan robot. So it's common to have a URDF for a robot. And so what do you do with this URDF to be able to start simulating? This is going to hit a couple different points from basically the advanced tutorials of Isaac Sim. It's going to hit some of robot import, extension templates, and then some motion generation. So I'm going to start Isaac Sim from the launcher. This is version 2022.2.1 that I'm using. So when you have a URDF, it's pretty easy to, assuming all your meshes are sorted and stuff, it's pretty easy to import your robot. You just go to Workflows, Isaac Utils, Workflows, URDF Importer. You get all these options, but essentially you do input file. Everything I have today is going to be in a folder I just made called My Working Directory. I saw there was this URDF in the folder that someone gave me. And if I click import, it imports, and that's it. Now I have the robot in here. It just read the URDF, made the kinematic tree, read the meshes and all that. But what are these options? Stage units in meters. That's like, you could have the stage units be like centimeters or something, but I don't want that. Then there's some default gains. Like if you send a joint command to this robot, it's going to use a PD controller to follow that command. So this is just setting a default constant for every joint. Self collision, like can you, if the robot hits itself, do you want it to like bounce off itself or not? And then import inertia tensor. If you don't have this checked, then it's going to like auto compute the inertia information from the meshes, I think. And if you do have this checked, it'll read it straight out of the URDF. So the first thing I'm going to do is I'm going to see, does this URDF have reasonable import inertia tensor information for if you did care about simulating it. What's my graphics card? I don't actually know off the top of my head. It is old. It's not a very new one. Is URDF an equivalent to USD or a derivative? No. So URDF is a universal robot description format, and that is the standard for basically like a lot of simulators and algorithms. Like ROS uses URDFs a lot. So if you're trying to bring a robot into the ROS ecosystem, or a lot of people's algorithms support URDF. And if you look at the URDF, I'm gonna in this directory. I'm going to look at this URDF, and so this is very common kind of format for robots. And so we have a URDF importer taking this common format and turning it into this uncommon format of USD, which is universal scene display. That's something that Omniverse uses. And so it as like, well, a universal scene display. So URDF is what you are likely to have for an industrial robot. And then you can bring it into Isaac Sim by using the importer. In the URDF file for this TechMan robot, it has like all the kinematic information. It has inertia information. And the fact that these are actually like specific values that aren't like 1 means that someone actually probably thought about these values. And so I'm going to say I want to import the inertia from the URDF. A lot of the time, people who make URDFs just write nonsense values here, and the inertia information is wrong. Okay, so you can do this, click import, and it's going to output to same as source. So I found the URDF in this folder, and it made this TechMan for Isaac.usd file. So now I have the TechMan robot USD file, and what can I do with that USD file? Well, if let's say I open a new stage, all I can do really right now is open this USD file, which that's all well and good. But it doesn't, like now the obvious next question is, what do we do next? I'm just going to glance over at the questions again. Oops. Graphics card, NVIDIA SMI, show us, don't be shy. All right, I got, I haven't had to look at this in a while. Well, for whoever told me to do NVIDIA SMI, they know where to look in here. My sphere collider is not stopping the self-collision of my arm joint. How do I resolve this? We will get there later, much later. For this comment, my sphere collider is not stopping the self-collision. Okay, I have this USD robot. I can't do anything with it. I don't know how to program it. No one told me how to program things in Isaac Sim. What do you do? Well, there's a new way that I'm going to rep today, which is to create, there's now extension templates that you can download onto your local machine that help you get started when you want to just make a standalone extension on your system that's going to do something useful with the robot. So Isaac utils, generate extension templates. I'm going to choose one called loaded scenario template. This is going to show me how to load a robot and make it do some stuff, some interesting stuff. So where do I want this extension? I want it in my working directory. And then I want it named like my extension. What's the title? My example extension, an example. Okay, I click generate. On the next release, there's going to be better visual confirmation that this works. But for now, if I look in my working directory, I now have my extension. This is a valid Isaac Sim extension. And so if I go to Windows extensions, I can now enable that new extension that I made on my system. If you click this gear, you can add a path where Isaac Sim should look for extensions on your local machine. So for me, that would be home, hey Rudich, desktop, what did I call it? My working directory. All right, it's going to look there for user extensions. And those user extensions will show up under third party. Here it is, my example extension. When you enable the template, it adds itself to the UI. So what's this template do? I picked one without saying what any of them were, but I picked the one I knew I wanted. This one gives you a load button. There's a specific robot, one of the Isaac Sim supported robots, the UR10, that gets loaded. And then what this scenario does is it just spins the robot. It just changes each joint in the robot one at a time. So the first thing I'll do is, instead of doing UR10, I'm going to do this with the TechMan robot. I am in my, okay. In these extension templates, I'll point out that there is a page on the Isaac Sim docs to read more in detail about how these are structured and which one you might want to choose for your application. I'm not going to get into that, but there is really only one Python file when you download one of these extension templates that you need to look at, and that's UI Builder. And what that does is it builds and allows you to program this UI. And it makes it really easy to customize. Like if I wanted to add a new button or add other UI components, it's all pretty easy to do inside this one class. So let me look at what happens. I have this load button, and it seems to load this UR10. So if I look at load button, I see that calls a function setup scene and setup scenario. So I'll just read the doc strings for these out loud. Setup scene, this function is attached to the load button. And when you press the load button, a new instance we have this object in Isaac Sim called world, or this concept called world, that basically bridges the gap between like, it just fills in the parts that you don't want to have to know about how the simulator works. And it's a class that like sets up, it just talks to the simulator and abstracts away all of the annoying stuff. And then this load button basically is like is setting up a world for you. And then what you do is you can when the load button is pressed, you write stuff in your setup scene function. It lets you load a robot of your choice or load whatever you want. Load a USD stage. You could load a stage that has all kinds of stuff in it. You could load whatever you want here. I load just this UR10, and there is also a floating cube. So instead of loading the UR10, I'm going to load the TechMan robot. So to do that, I will, let's see, I'm going to take the USD file I generated and maybe put it, I'll be lazy and just put it directly with my scripts. Or no, I'll put it in data where it should probably belong. All right, so now I have a USD file inside this extension. So I want to load this particular USD file. And so the path is going to be, I'll be lazy again and just type the absolute path. But you can get the relative path as well. Desktop, my working directory. And then my extension, data, pm12 or isaac.usd. Okay, so let's see if that works. These things hot reload. So when you change the code, it will immediately change the template. So if I load this now, I got some kind of error, which maybe my path is wrong. Let's see, invalid or, oh, okay. it's because there is nothing called UR10E anymore. So let's see. I'm going to open this file, which my working directory, this USD file. All right. The prim path of the robot is called TM12 /TM12. So that was something else that was wrong. TM12. Okay, let's see if this works now. And I realize I haven't looked at the, okay, that still has a lot of errors. Okay, this is just in an incorrect absolute path. So let's see. Maybe if I just do a relative path dot slash my, maybe it would be dot slash data. I'll have to maybe figure out this path thing. I wasn't planning to have bumps on the stream, but here I go. Okay, let's see. That's true, what they're saying about me. Okay, so what is the correct syntax for relative paths? I'm about to have to figure that out. There is a, here, I'm going to Google Python get your path and get path of current file. So I'm basically just going to print out I'm just going to print out, oh, I can do this. Okay. I'm going to print this out and then read it and see where I'm at. Okay, I'm in, okay, let's see. It tried to open, what did it try to open? I have definitely figured out this relative path thing before in a better way, but here I am blanking on live stream. I'm just trying to find the path of what I tried to open because that's why it failed. So, because up here it made itself kind of obvious. Could not open asset. Oh, here we go. Oh, because of relative path. Sure. So if I can just get the directory of this file, so Python get current directory, get current, all right. That looks good to me. This is real development in progress. Okay, so there is what's the path to this file, and then I want that path, the path to this file, which is going to be in scripts, and then os.path.join that directory path with probably ./data/tm12 for issac.usd. All right, let's hope that works. No, it didn't work. All right, this is not the best thing to be showing off. Hey, okay, this one actually seems right. Could not open that asset. Why? Is there maybe It looks like that path was this path seems totally right. So I don't know why there's a problem. Okay, so I just copied this. And again, sorry, I'm not figuring this out in the right way. But at this point, I just want to move on because this is not what I planned to stream about. Yeah. So path to robot USD is equal to that plus that. And forget about this. We don't care about this. All right. We are just. No, it didn't load. Let's see. Could not open asset. This. Well, maybe I do need to figure out how to reference this in the right way. This is the one thing I didn't test run before doing this live stream. Okay, so there is something I've seen before that lets you get the path of the extension you're in. Is anyone telling me how to do it? OS.get path. Everyone has path problems. Problem solved here. Help us all. Okay. Have I don't quite understand that question, Brainicorn. Okay. No problem. This will help us all. What a supportive community. Thank you. Okay. So this is not working, giving the absolute path, which that is honestly surprising me because I can see that this path, opening this asset in Isaac Sim directly does work. So it has some warnings that I won't try to get into yet because I'm not there. But so that's kind of surprising that. So, okay, maybe I can try. There's this useful thing in Isaac Sim called script editor. You can just run code from it. I'm going to try. Oops. I'm going to try this. Putting this code in the script editor and seeing if that runs. And it did it. Oh, I can. Okay. Create new stage is not defined. Of course it's not. Okay, and it. All right, so there's a problem. Could not open asset for reference on prim. Why? Why couldn't it do that? Man. Init.py has to import the files to load the URDF or USD module. I still am not sure I understand. Okay, so we're seeing in isolation what doesn't work, which is I have this absolute path, and just to make absolutely sure that this is the right absolute path, I'm gonna, I guess, look in my terminal and yeah, see that the file I want is indeed at that path, that absolute path. It's called tm for isaac.usd, and why? Add reference to stage. Okay, some assets are in the cloud. Okay, but if it's a local asset, you can just open it programmatically without a problem. I've definitely seen that done before. I've done it myself. But yeah, so there is a different, I don't know, there's from Omni dot, there's a different thing. And I could, there's also open stage, which maybe I'm just going to try that. Open stage path to robot USD. What does this one do? This failed. And it just failed to open this file without giving me a reason. Darn. Okay. Well. Could not open asset at. Maybe someone. Okay. I don't know why this is happening. You are able to open a local USD file. For example, in this content browser, in this content browser, you are, I'm opening a local USD file. It works just fine. And so that's why this is pretty surprising that opening the path to my local USD isn't working. So I'm going to pivot. I'm going to pivot without destroying the, I'm going to pivot without losing what I was going to do because I've spent too long on this. And I'm sorry that I didn't figure out why this happened. So I'll try to figure out where to post a good follow-up to this. Okay, what I'm going to do is I'm going to use a different extension template called configuration tooling template that, and then I'm going to use it not for its intended purpose. So I want it to be called my other extension title, this one now. Okay. So what does this other extension template do? I'll disable this first one. And I wanted, what did I call that? My other extension. Okay. This one now. All right. This one finds whatever articulation is currently on the stage and then like connects to it. And it makes an example of like, of being able to modify the joints on that articulation. So this one's still workable. My other extension, I have, all right, now this, all right, we're back in business. You know, there's a thing that builds the UI, that builds like this box and this robot control frame, and lets you sort of manually move the robot around. This is a useful template if you're building some kind of like debugging tool to get a good view or like get direct control into what the robot's doing. Oh, Brainicorn got the correct path. Needed proper pathing. So I don't think it's related to needing any init.py because for some reason this is failing just from the script editor. Is like usually this kind of thing, like opening a stage programmatically from here works without, and this is just straight up a Python script that you get to run from inside issac_sim. So really, you can definitely just have code to open a local USD file, and I don't know what went wrong. Getting back to this. Okay, so there is an articulation in this code. If I Control F for articulation, let's see, I must have this selection menu lets you get an articulation. When that articulation is selected, There's this line, capital articulation of selection. So selection is the prim path of this robot, TM12. And then the line, from our the line articulation, or like import articulation. So what this line does, to make an articulation for a robot, you are, this is what the code looks like. And you would, what this can do is like directly command this object would be able to command the joint angles on the robot. So that's what's happening in here, is that there is a self.articulation that becomes whatever you selected in the drop-down menu. And so let's say I want to, I'm going to make a new thing, which is going to have the robot go to like a target using RMP flow. And I'm not going to use the like built-in, the RMP flow controller stuff. I'm going to do that all from scratch because it's nicer to show you how. And basically this, I would have been at this step 15 minutes ago, if not for that pathing. So I'm going to modify this UI so that there's some kind of button that activates RMP flow. So in build UI, this is the function that built the UI. And I'm going to make a run frame, or I don't know, go to target frame. It's going to be a collapsible frame that means you can do this. A collapsible frame called go to target that, well, I don't really, it can start out collapsed. I don't care. And then you can, it's pretty easy syntax to get used to. Inside that collapsible frame, I'm going to say I want a use RMP flow button is going to be button. I don't have button imported, but there is a thing called button. And the thing called button can be found either in that other template, or it can be found in, if you go to the API docs for Isaac Sim and look under UI utilities, there is a thing, a class called button that will just make you a button with common sense kind of features. So I was making myself a button. So use RMP flow button is a button called use RMP flow. This is the text next to the button is the first argument. The text on the button can say run. And then the last thing I need is an onClick function, which is the function that will be called when the button is pressed. So def on pressed RMP flow function self. Okay, this button is going to make RMP flow happen. And for now, it'll pass. I need to go back to my button and say self dot on. This is all done better in the other template. So I wish that I had been able to use that. Okay. On pressed. Yeah. Okay. So, and you know what? I'll just print hi to show that it works. Okay. Is hi getting printed? Yep. Okay. So we have a button. it makes something happen. And I'm just going to assume that if this stop button has been pressed, it will mean that there is no it'll mean that no articulation shows up and nothing is going to work. I'm going to assume, without making it safe or being careful, that when this run function is pressed, there is a selected articulation, or I'll say if self.articulation is none, do nothing. Okay. So if there's a working articulation, I'm going to assume it's been that the timeline's playing and everything's in the right state. And I believe that is a correct assumption in this case. Okay, so make RMP flow happen. But how? Well, I don't know yet. Or I can't do it yet because I haven't configured RMP flow. And that's where I'm going to lead into. But now that I have this button ready to fill in, once RMP flow is ready, then I'm going to get there as quickly as possible. For now, let's just say self.articulation. How many degrees of freedom does this have? 6. Dot set or self.articulation dot set apply. This is another bit of syntax. So an articulation has an apply action function. And I'm just going to use in articulation action. This is just sending a joint target. And for now, I'll do, this is just to show that the buttons work. So this is a 6DOF robot. I'm going to send an articulation action saying that every joint should go to the 1 position. And I'm saving. It's going to hot reload. All right, so if I press this, look at that. So now you can see how if I start adding in RMP flow stuff, like a button that makes it start using RMP flow to follow a target, then that's all going to work. But how is the code completion enabled in VS Code for your extension? I'm not I forget what VS Code extension I have that does that. It's like the most, if you just look for I don't know, packages. I always forget how to do this. I just looked up the most common VS Code Python auto completion package that was, free, and downloaded that one. So nothing special. Can we create our ROS interface for any user in Omniverse? I don't know how to answer that question. Sorry, I haven't done any ROS stuff with Omniverse personally. Glad someone liked that example. Okay, back to it. I'm going to set up RMP flow for this TechMan robot. What you need to set up RMP flow is, RMP flow lets you avoid obstacles and follow a target. So to set it up for this robot, there's 2 things you need. The corresponding tutorial would be configuring RMP flow for a new manipulator. And so there's 2 files you need apart from the URDF in order to set up RMP flow on a new robot. One of them is a robot description file. And so I'm going to create a robot description file using an Isaac Sim tool called Robot Description Editor. And at the end, this is going to spit out one of the 2 files needed for RMP flow. So what is this? RMP flow is an algorithm that you pass in world state and you set a target and you want the robot to go to that target. The algorithm is not reading the USD file of the robot. It reads the URDF of the robot. And so you need to have a URDF of the robot. The algorithm itself is completely independent from Isaac Sim. We just wrapped it to be able to use it within Isaac Sim. And then it needs to know some other fundamental information about the robot. So if you use the robot description editor, it will tell you what information is necessary for you to set about in order for RMP Flow to know about this robot. There's two main things. One is what joints in the robot should RMP Flow care about. So that's not necessarily every single joint in the robot. If this robot had a gripper attached to it, which it does not, but if it did have a gripper attached to it, you wouldn't want RMP Flow to command the gripper joints as well as the arm joints if you were trying to send it to a target, because the gripper is probably supposed to be used for gripping, and you want the arm to move the robot to a target, not the gripper. So there's this panel that lets you see every joint in the robot. Is similar to that template I wrote because I was writing the template to support use cases like this one. In that panel, there's joint status is, you can say which joints RMP Flow is supposed to care about. So for this robot, all 6 joints are joints that control the arm of the robot. And then if you wanted to attach a gripper, that would be all good. But the RMP Flow, the way I'm going to configure it for this robot is that it should take control over all of the joints in this robot. And it's going to, assume that no one else is messing with the joint control at the same time for those 6 joints. So then joint position, this one, apart from you just being able to move the robot around, and that's fun, this is what RMP Flow should consider to be like a good default position for the robot. So like if there's multiple ways to reach a target, it will nominally like mostly choose the way that's closest to the default position. So the default positions that we set for a lot of the supported robots that have RMP Flow config set up, the default position we set is usually aligned with the x-axis, assuming that the positive x-axis, this red line, is the front of the robot. And then this stuff, like basically imagine that you're going to use this for some kind of like reach and manipulate task. Then a reasonable default joint position would be like extended in front of the robot. So I'm done with this panel. I've said that RMP Flow should care about every joint in the robot, and that it should, if possible, tend towards this position when reaching a target or when avoiding obstacles. But it doesn't, this isn't, it's not going to be forced to do this. It'll just kind of be pulled back towards this position while achieving other tasks. And what is the default velocity for the robot? So you mean default velocity constraints for the robot, like joint velocity constraints? Is that what you mean? So those are written into the URDF. This one, and are imported from it. So if I like, it looks like the velocity limits for this robot, which is made up of revolute joints, is like 2 radians per second for shoulder joint 1. Let's see, 2 radians per second. Oh, they like this 2.09 number. Okay, this one can go pi radians per second. And you can see that from so the USD was imported from URDF. So we should see that information has been correctly imported. So you can in this view on the side on your stage, you can like expand the robot and then go and pick a joint from the kinematic tree of the robot. So let's say shoulder joint, that is linking link 0 to link 1, which we can see here. And upper limit, this is in degrees. So upper limit 270, lower limit negative 270. And then let's see, joint state. Oh, okay. So what is actually true, I forgot this while I was answering your question. the USD robot is not actually going to care about velocity constraints, and is relying on you, the commander of the robot. If you care about velocity constraints, then you can, when you can send a more detailed action to the robot. Like what I did was when I made this action that sends the robot to the all ones position, and really this is filling in the joint positions argument. But there's also, when you have an articulation action, you can have joint velocities is equal to something. So if you had a maximum velocity in mind when controlling the robot, if you command it, the simulated USD robot will do it. So if you have joint velocities in mind, then you would basically send it a trajectory that is going to have velocity commands included. And so, like, you're not likely to really interact with the robot at the level of like coming up with an action that tells it to move like all the way across the stage. Like you're probably going to send it in action on every frame rather than sending it in action like once and letting it go there with a PD controller of sort of like unknown behavior. Or like you can see the tuning of the PD controller as one of the properties of the joint, but you usually would want to get like more fine-grained control. One of the algorithms that takes more fine-grained control over the robot and will allow you to send a position and velocity constraint, or a position and velocity target on every frame, is RMP flow. And so you can tell RMP flow maximum velocities for the robot joints, and it won't exceed that when it's rolling it out. Okay, cool. Glad I answered your question. Okay, so then what's the rest of this? If I clicked export right now, this would be what this would create right now is a robot description file that is good enough for RMP flow. It answered the question, where is the default position and what joints do I care about? But it wouldn't avoid any obstacles because RMP flow is not reading the meshes from the URDF to do collision avoidance. Instead, it relies on collision spheres. So you can make collision spheres for a robot as part of this editor. And that's mostly what this tool does, is allow you to quickly make collision spheres. And what that looks like is for each link, one at a time, you are placing spheres that RMP flow is not going to allow to collide with the environment. So if you imagine that this whole robot can be moved around, for the sake of time, I'm only going to create spheres on the later links in the robot. Like, let's see what okay, so there's, let's say I want to create spheres for this link. What that looks like is there's a generate spheres button, and then there's a way to do it manually. If I do it manually, I can like create a sphere, move it around, resize it. Maybe I want it of 0.08. I could, if I click this button here, it changes the coordinate axis. This sphere got added to the link in the USD structure of the robot. So if you click this button and it glows orange, then it will show you the coordinate axis that's aligned with wherever your prim is nested. So this collision sphere has the pose of link 3. There's a tutorial in our docs that shows like doing this in its entirety. So I'm just going to do this very fast and not very well. But for this link, I can do something like, say, I want 7. I can make 7 spheres that represent this link. And then I would do that for other links. So, you can see this robot's going to be extra conservative about like this link hitting anything, because it's not going to allow these spheres, which will be invisible at runtime, to hit anything. And so let's, keeping up the theme of doing this as quickly as possible to catch up on time. If I go to one of the later links, like link 5, what's that one look like? That's this. I'm just going to make one big sphere. Okay, I'm just going to leave the robot like this. It's going to be possible. It'll be happy to make it collide with stuff with this lower link, but I'm going to at least give it collision avoidance for this part of the robot. And then later we'll see that in action. So now that I've come up with spheres that I am happy with for this robot, I will say export and output file. Where should this go? I'll put it in my other extension. Well, I don't know. How about in data, RMP flow, or this is a robot description file, not pi, no, it's a robot description file, and it's a YAML file, which I think would be auto appended for you. Okay. And I click save. Now in this data folder, I have this robot description file. What it looks like, you never have to look at it, but it has like the joints RMP flow should care about, the default position of the robot, and then those collision spheres that I made, defined on a per link basis. Okay, so that's half of what you need, and it's faster if you're not talking through it and all that. But like this is half of what you need to run RMP flow. The other half, luckily, takes almost no time. So if I go to the configuring RMP flow for a new manipulator tutorial, then it says you need a URDF, you need a robot description file, and you need an RMP flow config file. RMP flow config file looks like this, and I'm just going to copy paste this default one, or this tutorial one, and I'm going to, in VS Code, in data, I'm going to say new file, RMP flow config.yaml. I'm going to paste that. Okay, this is a bunch of hyperparameters for RMP flow, none of which you almost ever need to care about. We have a guide explaining what all of them are if you care to tune them for your purposes, but these parameters are chosen for a robot of similar kinematic structure and similar size, and so they're probably good enough. There's only 3 things to do to make these parameters that were set up for this other robot, this guy, Kobata. There's only 3 things to do. One is, this is per degree of freedom, and I'm seeing 7 things here, but there's only 6 degrees of freedom in the robot that I just set up. So that's the first thing, is I'm going to make the number of degrees of freedom right. What this argument is doing is saying that RMP flow is going to not let the joints come within 0.01 radians of their limits. Then, not touching these at all, I'm going to skip to the bottom, where this is now coming back to someone's question about how do you make RMP flow avoid self-collision? Well, we're going to figure that out in a way that's like really complete and concrete. But right now, there is a way that is like good enough, which is that there is these 2 arguments, body cylinders and body collision controllers. And a body cylinder is implicitly defined around the base of the robot. So it would be like around here. And if you make a body cylinder, then then anything that's a body collision controller is not going to be allowed to hit anything that's part of a body cylinder. And that sounds like a very incomplete way of not allowing self-collision, and it's true. But Practically, it works because like usually robots are built so that they're not really like there's not a lot of joint configurations where they are able to hit themselves. So if you just kind of make the end effector not able to hit the base, or you set a zone around the base using this body cylinder argument where the end effector can't go, then you end up not having self collision. So no, the cylinder is implicitly or the cylinder is defined like in absolute coordinates. It's not like there is no frame called base. It's just nested or like so this is saying that there's an invisible cylinder between 000 right under the robot and then 0.333 of width 0.05. I'm going to use the robot description editor just to see if 0.05 is a good size for that cylinder. So, well, it's invisible, so it must not be a very good size. How about 0.1, 0.15? Okay, I'm just gonna say there's a big fat zone of 0.15 meters around the robot base that shouldn't be hit. Not the base. They are light but noticeable. Yeah, so RMP flow is if you are having self collisions in the intermediate part of the arm, then I mean, basically, like this way that was left the way it is, and not like really a completed self collision avoidance feature. That way is because it works good enough if you're doing things like in front of the robot. But it is true that you can, if you're like having RMP flow move around in a really like cramped space and it's like very tight, then you can get it to hit itself. And we are going to add support so that it will do a more general thing. But it was left the way it is because it really is good enough for most actual like industrial robot manipulation applications, like because the workspace you're working in doesn't end up having self collisions be a problem. Okay, so then I need to say what frames can I'll say that the link 6 frame is going to have an invisible sphere around it to avoid there's no frame called end effector. So link 6. And all of this has like a more detailed tutorial on the docs. So this is like a reference for, like you might want to reference the docs if you want to like, I'm not going to spend too long on like how I came to this exactly, but I'm just saying link 6 shouldn't hit this invisible area around the base. Okay, so now I supposedly have everything I need for my config. I have RMP flow config and robot description, and I have URDF. I'm going to copy the URDF. I'm realizing that okay, I'm going to copy the URDF into my local extension, paste. All right, now I have this data folder that has all the stuff. I'm realizing that I can see a world where I have file path issues again, but I know a way around it if that happens. So, okay, RMP flow config. I have all the files I am supposed to need. So now, what do I do? I'm going to open up, get rid of these spheres. Okay, so these spheres that got created by the robot description editor, those do not stay in the USD file. Those are just for visualization while you are making the collision spheres that RMP flow is going to use. So these RMP flow is using these things as config files. It has a description of the robot that says that there are spheres that it should care about for collision purposes. The USD file doesn't have those spheres. They were like added to the kinematic structure while using the robot description editor. Okay, so select this robot. Okay, and now go to target. use RMP flow. That's not going to, that's currently not hooked up to RMP flow. So I'm going to go back to that function and I'm going to try and make RMP flow happen. So to do that, I'm going to reference the RMP flow, configuring RMP flow tutorial. And this tutorial is written to run a simple demo that uses RMP flow from a standalone script. So I have right here the way that you can make the RMP flow algorithm. So RMP flow algorithm living somewhere in Isaac Sim. From the tutorial, I'm going to learn where to import that from. Okay, and I'll go up, add those as imports. Okay, looks like I also had OS in here. Okay, so you then RMP flow is an algorithm. You pass it the paths to your files. So let's see if I can. Well, I'm just going to. What is there? There's a copy path, right? Or yeah. So RMP flow config copy path. So the config path is this. All right, so let's see if these work. And then that will give me some information about whether the bug I was having before was something to do with specifically trying to open it as a USD file, or whether I'm just doing something completely wrong. Okay, then robot description file, copy path. Okay, and then end effector frame name. This one's kind of, I have to get right. What should RMP flow consider to be the end effector frame? It can be any frame that exists in the robot URDF. Since the USD was created from the URDF, I know that any frame in the USD is also in the URDF. So tool 0, I'll just use that for now. It does look like tool 0. I don't know what this like little white bump on the end is, but it does look like where tool 0 is an acceptable end effector frame. And the tutorial, so this frame, tool 0. Okay. This parameter you don't need to worry about. Okay. And I need a comma. Okay. Let's see if this works. If just importing RMP flow works. Oh, yeah, there was no error. So that makes me think that RMP flow did work. All right. Now we have RMP flow, which this is, again, an algorithm that is not talking directly to the USD robot. It's an algorithm where you can pass the robot state. And then is there a link to the tutorial? That is a good point. The tutorials I'm looking at are all under advanced tutorials. So by giving you a link to this one with configure RMP flow for a new manipulator, I'm going to be giving you a link. You know, you're close to all of them. Okay, so, and I'll start posting the links to the tutorials I'm referencing in the chat as I do. That's a good idea. So RMP flow is an algorithm that knows, you can tell it the robot state and it will tell you what should the robot do. And it will give you, and it's not making a plan, it is making an action. So like you give it robot state, world state, and then you, and then it tells you what you should do on the next frame. So you can say like, you can specify the time step on which you want, you can specify the time step. So in this example, in the tutorial I just linked to, there is so there's RMP flow this class wraps the straight up RMP flow algorithm, which you are not going to want to use directly. So then there is a sort of intermediate helper class called articulation motion policy. RMP flow is considered a motion policy, which makes it something that takes in robot state and outputs an action for the next time step. And you're supposed to call it over and over again on every time step. But you don't have to actually know how to link RMP flow to the robot articulation. There's a class that does that for you. So, this class, self.articulation. So I'm going to create this object, which is going to be able to link together the USD articulation and the RMP flow algorithm. And then physics DT, the simulator currently for me is locked at 1/60. That is probably, well, that is the default behavior, that the physics step is 1/60th of a second. So we're telling RMP flow that it should come up with an action for 1/60th of a second from now. And if we command that on every frame, then, we get the desired behavior. So then in some kind of on every frame, I'm going to want to do this thing, which I'll have to modify, but def on every frame self. And again, this would be easier if I had been able to get the other template working without that loading issue. On every frame, I'm going to say RMP flow. Here, let's say that the target position is just it's just on the x-axis. So self.rmp flow, self.rmp flow, self.this thing. Okay. So on every frame, RMP flow is, for the first thing I'm going to do is set a constant target. Then what's going to happen is it's going to ask articulation RMP flow, what is an action that is suitable to pass to the self.articulation.apply action. Okay, it's going to ask RMP flow, what is an action that is suitable to pass to the robot articulation, the USD robot? Okay, nothing is calling on every frame. And so now I'm going to have something, if self.rmp flow is not none, or is none, then I'll just return and do nothing. Is none, then just return. Okay, and in my init, none, self.articulation RMP flow equals none. Okay. So on every frame, do this thing. I need to call on every frame somewhere. And that somewhere, well, there is one of the things in this template is this on physics step of function, which is called on every physics step. And a physics step is on every frame when the timeline is playing. So right now there's a physics step happening on every frame, but there's nothing interesting is, actually going to happen because there's nothing doing anything. So I'm going to have self dot on, maybe I didn't give it an underscore, on every frame. If RMP flow is alive, it's going to take command of the robot to move it to the position 100. That's what should happen. Okay, let's see. No, nothing happened. Arg. Okay. So, and returning. Run. Is it printing returning over and over? No, it's not. Okay. Well, nothing. All right. Is this showing me a bug in this template? Because I should have the word nothing printing over and over. Okay, on physics step, that appears to have some issue. Whatever, I don't need that. Well, I think I would want it. There's really nothing happening here. Hello? Why do you do this to me? Oh, okay, now it's printing out hello all the time. So oh, well, it was probably a small bug, which I will fix in this template, where when I hot reloaded the extension while the timeline is playing, it didn't subscribe to the physics correctly because the timeline was already playing. So I'll address that. But if I stop and play, then I can get the physics subscription to be made successfully. And if it's stopped, you can see physics isn't running because it's not spamming out hello anymore. Okay, now I will say self dot on every frame. And so on every frame, it's supposed to do this. It's going to print returning before RMP flow is initialized. So I should see returning, returning, returning. Okay, if I press this button, oh, hell yeah. Okay, look at that. It is using RMP flow to move the robot to 1, 0, 0. Okay, is a physics step the same as a tick? That's a good question. A tick is, so a tick can mean like the conglomeration of all of the different stepping that needs to happen. And that behavior is non-trivial to explain, but like there in essence, there is, when there's a tick, there could be a physics step, there could be a rendering step, or there could be both. So if physics and rendering are happening at different rates, then like I think tick would encompass either one. In general, if physics and rendering are supposed to happen on the same like tick, then physics is going to go first. So I think physics step is a subset of what tick could be. I don't know about jets and nanos. Yeah, Hydra, I apologize. Okay, our arm on play also does crazy dancing seizures from time to time. Can we account for? Well, you're using RMP flow and it does crazy dancing seizures. The crowd wants to know. Okay, but back to this while you answer. Now, okay, so if RMP flow is doing that, okay, that is not likely to be something that RMP flow would be willing to make the robot do. But I'm not telling you you're wrong. I will just, I'll push your question back a little and I'll come to that at the end. Okay, so I got the robot to go to a target. This is a little lame because RMP flow can be used not just for a constant target, it could be used for a moving target. So I'm going to do on pressed RMP flow function. I'm going to make a cube. So from omni.issac.core.objects.cuboid import fixed cuboid. This is just going to make a cube programmatically on the stage. Cuboid. Okay, and when you set up RMP flow, I'm going to say self.cuboid is equal to fixed cuboid. And the path can be slash cube. The position can be 1, 0, 0, and the scale, it's going to default to be 1 by 1 by 1, which is 1 meter by 1 meter by 1 meter. So I'm going to give it a scale of 0.01. And then what I'm going to do is I'm going to have RMP flow go wherever the cuboid is. Target position is self.cuboid.get at world pose. I have the API kind of memorized here. Sorry, but okay. Cuboid is a prim created programmatically. You can get his world pose, which is going to return position and orientation. If I want RMP flow to have to match both, target orientation is equal to this thing. Okay, and that's obviously an inefficient way to do it. Okay, I've learned that because of a bug, I need to stop and play. If I click run, the cube was huge. There was, and I can't see my bug because I decided to spam myself with print statements. Okay, deleting that. Okay. This one now. Run. Okay. What did I do wrong? Set local. Okay. The argument wasn't scale. It was scale is a different thing. If you wanted the scale would be a 3D argument for the height, width, and length of the cube. Size scales the entire thing. Okay, and I'm going to delete this cube. Right, so ideally you would have some kind of loading loop for managing your stage so that you don't have to delete stuff manually. That's what that other template does. Whoa, woo. Okay, that's pretty bad. Now is the perfect time to get to your question, Monkey Tang, because the robot is absolutely not doing what I wanted to do. And also, that cube is clearly too small. So maybe I want size of 0.1. That's the first thing I'll test out. Okay, RMP flow is totally failing to follow this, target. Run. All right, that's a better looking cube. Oh, it tried to hit the cube and then went crazy. Okay, so it went crazy. We saw that RMP flow was doing an okay job of moving the robot around before it got some interference, and then it ran into the cube, and then physics responded by giving it a push. Basically, you like get out of this cube, and then RMP flow never recovered. What's happening? Why I'm getting this weird behavior is RMP flow never recovered because there's two things at play here. There's the RMP flow algorithm, which outputs joint and position and velocity targets on every frame, and then it gives those to we saw that line apply action, articulation.apply action, and so apply action gives the joint and position and velocity targets to the USD articulation and says, please go there in the next frame. And then what if this robot didn't go exactly where RMP flow wanted it to go? What if it only got halfway to those joint and to those position and velocity targets? Or the velocity wasn't met nearly even at all? Then what the RMP flow, then you enter some kind of uncomfortable feedback loop between the PD controller of the robot and RMP flow, the algorithm, because RMP flow really just is assuming that the robot's going to be good at going where it's told. And if the robot is not good at going where it's told, it appears that with like a push from physics, when there's a collision with this cube, the robot, it never recovers. The feedback loop is unstable. There's a simple solution here, which is that if RMP flow is expecting the simulated robot to go where it's told, then all we have to do is self.articulation.set gains. It's set very stiff gains. It's a 6-stop robot. So this is going to be the positional gains is the first argument. And I'm going to say 1e15, like very stiff gains. And then the damping gains can be 10 times less ones. So you don't always basically, if you care about the dynamics of the robot being simulated accurately at the level of USD, you wouldn't set infinitely stiff gains, because now if I send an action that's like far away and said get there on the next frame, with very stiff gains, the simulator will be willing to basically teleport the robot to that place. But since I know I'm using RMP flow, I want the simulator to just let RMP flow call the shots about exactly what the robot should be doing. That's why it's okay to set like stiff gains in order to use RMP flow. All right. And it has no attribute set gains. I could have sworn it did. Okay. No problem. Because here is the API docs for Omni issac core. And if I control F for gains, get gains, set gains. Hey. Articulation has no attribute set gains. But it says here that it does. So did I do something? I do something. First argument is KPs. Second argument is KDs. Okay. Well. Oh, wait. Now, I've used this line before, and it's showing up in the API docs. So I'm not sure what the confusion is there. 10 times less is a good rule of thumb for PD tuning, yes. Okay, so, well, get, there's some, articulation controller. Okay, there's maybe things were moved around and the documentation didn't stay exactly up to date. I'm going to follow up on this. Okay, there is inside articulation, it has a thing called articulation controller, which I know happens to no. Oh, but there's no errors. So, oh, that was that physics. Okay. All right. So now I set the gains very stiff. And it's no longer going crazy. This cube, it is following the cube. Notice that it's a lot slower than it was before. And that is, and thank you. I did forget. Okay, the cube is a lot slower than it was before. Or I mean, the robot is a lot slower than it was before. And this slowness is the speed that RMP flow, the algorithm, was actually telling the robot to go. But it was just overshooting because the gains weren't stiff. So now we're seeing a more true version. And I can have these nasty unintended physics collisions. And it doesn't make the robot go crazy. If this is too slow, which I think it is, it's not very aesthetic to me. They're in the RMP flow config. I said you don't need to worry about any of these. What I actually mean is that you don't need to worry about any of these, but if it's too slow, this thing, target RMP, if you change it to have a bigger proportional gain, it's going to be pulled towards the target more. So if I change this to 100, hopefully, you know, and I wasn't careful when doing this. So I'm just gonna hot reload the extension to make sure RMP flow does get initialized again. Okay, run. All right, now it's faster, but okay, because RMP flow, the algorithm has gotten faster. Okay, it's kind of silly to be setting a target that RMP flow is going to collide with, because I'm not telling RMP flow that that cube is an obstacle. I'm telling it it's a target. So it's not expecting that to be collidable. So that fixed cuboid is a cuboid with collision behavior. Visual cuboid is a cuboid that you cannot collide with. It's just there to be pretty. So I'm going to say the target cuboid is a visual cuboid. And now I'll have a obstacle cuboid is a fixed cuboid. And this one I'll let RMP flow know is an obstacle. So slash obstacle. Position is it should be in the way. So how about at 0.8, 0.1, 0.1, I'm going to say size is equal to 0.1, and then scale, I'm going to make it like kind of wall shaped. So maybe the X and Y, or the Y and Z dimensions can be bigger. So like 5, 5, something like this. Okay. Now, target cuboid is going to follow the target cuboid. I'm going to tell the RMP flow algorithm, RMP flow dot add obstacle self dot target cuboid. Okay. Yeah. So okay. RMP flow is going to know about this cuboid now, and so I'm going to do pause and play. Okay, run. No. Oh, it didn't. It doesn't like. What doesn't it like? Array got an unexpected keyword argument. Oh, that's why. All right. Go to target. Okay, now there's a little wall and there's a little cube. I could have changed the colors. I'm being pretty lazy here. And I click run, and I must have forgotten, done something wrong. Because, well, it sure looks right to me right now. Target cuboid is this. I'm just going to hot reload this again. If I had those load, yeah, okay. No, nothing is happening when I click run, and it's not complaining, so I don't have any errors. So why is that? Print hello. Is this on every frame guy getting called? When RMP flow, oh, okay. All I had to do was try and prove that it wouldn't work. Okay, here we see the robot, it's not willing to move the arm into the obstacle because we set those collision spheres, and it's willing to get about as close as I made the spheres thick. And if I move this obstacle, once you tell RMP flow about the obstacle, it's going to stay up to date about it, about where the obstacle is. Okay. Oh, I see that this, oh, cool, way better. Brilliant collision detection. Don't forget that, oh, yeah, okay. Okay, so first, I don't need this anymore. We already know how. Okay, this cube that is supposed to be the target, for some reason, the robot is still able to collide with. And I think that's because I must have the wrong idea about visual cuboids, because it certainly absolutely used to mean that you are making a cuboid that is not collidable. So maybe there's a new setting that I don't know about. I'm just going to compromise and say that the target is very small. And this is going to magically solve the problem, because this is going to magically solve the problem, because instead of it's going to look like it reached the target. Of course, this is, well, right. This cube, I meant to make it not collidable. I'm not going to take the time to figure out why it is still collidable. I just must have outdated information about the API. But now we can see some kind of satisfying stuff. If I rotate this cube, because we're sending this as the target to RMP flow, it's going to rotate the target for RMP flow. If it weren't able to collide with the cube at all, there wouldn't have been any janky behavior. What is the recommended way of sharing objects between OmniGraph nodes? You can't share arbitrary objects between OmniGraph nodes. The typing, when you set up the nodes, the typing is like specified at runtime, and it's basically only like known Python, like C++ types are basically what you can pass between OmniGraph nodes. So it can't be arbitrary Python types. Okay, wouldn't that be self.visual cuboid, line 169? Oh, thank you for finding my problem. Or obstacle cuboid. Yeah, that is so. Okay, so let's see. Let's see if that fixed everything. Thank you. Okay. If I move this wall up, RMP flow knows about the wall. Okay, but what if I have this target here? Ooh. Well, that didn't look like it did a very good job avoiding the wall. But remember, I was lazy with these collision spheres. All right, you know what I'm going to do to make this? I am going to not include orientation as part of the target, because as soon as orientation is part of the target for a 6 degree of freedom robot, there's really only one configuration it can be in. And so if I want to show that this is actually working, it will be much more obvious if, okay, so if I move this up, or let's see, okay. So I guess what I'm trying to prove to myself is that the wall is not just hitting the robot out of the way, and that RMP flow is indeed reacting. And to make that clear, I'm going to make the wall not collidable at all, because someone pointed out I had just told RMP flow that the target was also an obstacle, and that's conflicting information. Okay, so this wall is not collidable. If I well, no. Okay, I think the visual cuboid is indeed collidable these days. The robot has learned to escape. All right, this is physics collisions. Okay, so the question is, oh, here we see RMP flows like, no, I don't want to get hit by that. That's good. So this is functioning. not with the very best of spheres. So let's say I move the target behind the wall. RMP flow is like, no, I'm not going to run into that wall. And if I move the wall a little away, maybe it gets a little more possible. So RMP flow is like choosing locally optimal things. So it's not making a plan. It's just making a locally optimal choice to move towards the target, but not hit obstacles on every frame. So if I right, if I like give it some help, it is usually pretty good about moving around walls and stuff. But I might have just given it a problem that it's not like super set up for success here. With this wall, there's not really anything it can do to get around the wall to the target. Okay. I made an extension for use with OmniGraph. What is the recommended way of sharing? Oh, I answered that. Okay. So I didn't, this all would have been more beautiful if I hadn't had that problem earlier with being unable to load my local USD path. I'm going to look into that. But what have I covered here? Is when you yeah, exactly, to the Terminator comment. When you load RMP flow, or in order to get RMP flow working on a new robot, these are really like, this is really all the lines you need to use the RMP flow action. So someone mentioned before the RMP flow controller thing, and there is a reason that the RMP flow tutorials are not written to use that RMP flow controller. They are written to use the code directly, and it's because it's, you know, easier to it's easier to understand that way. RMP flow controller, what that is doing, that is a wrapper class that basically does multiple of these lines for you, but in doing that makes it like so that people don't really understand what's going on. And so for like supported robots, someone wrote a wrapper class that like basically hides all of this and like loads it using internal magic. And you just think, oh, this is working somehow. So the reason I chose to present it to you this way is because like you actually see, oh, what is the call that requires the 3 files that I need to use RMP flow? And then once I have the RMP flow object, what can I do with it? And so that's how the RMP flow specific tutorials are written. And the, so if you try and figure out what's going on from reading the Omni issac examples, you will probably have a harder time than if you just directly read the RMP flow tutorials. And the extension templates are there as a sort of replacement for how, like, if you're coming into issac sim, how you would want to get started, because it puts everything in one place and allows you to like modify the UI on the fly. It's just much more readable. The examples were really written the way they were to make it easy for internal people to make examples that follow a kind of framework, but it ended up like sort of uncomfortably imposing that framework on others. So that's what the templates are there for. Is it possible to use RMP flow for inverse kinematics to control the arm of a 3D human character rather than a tedious manual animation? Well, probably. That's very possible. There's also, I'm not gonna make it work. I'm already way over time, but there is a Lula kinematic solver to solve inverse kinematics. All this one requires is the robot description file, so, and the URDF, which are 2 of the 3 things we needed for RMP flow. So you can reference the Lula kinematic solver for solving kinematics. If you got RMP flow working, then the Lula kinematic solver will work. That also goes for the trajectory generator, RRT, and well, that's what we have right now. Will you cover the Lula kinematic solver in a near future session? Well, not, I wasn't planning on it, but the like there is a tutorial, Lua kinematic solver, and the tutorial gives you like, here is highlighted every, well, a subset of what is highlighted is every line you need to actually make the kinematic solver happen. It's just as few lines as RMP flow. Okay, well, glad you found it super interesting. I'm sorry about trying to use one template for this that is supposed to be the new super easy and foolproof way of making an extension rapidly that has like really clean load and reset behavior. I didn't get to show that to you. RMP flow and kinematic solver are not the same thing. Kinematic solver is just going to spit out, you give it a target, it will spit out the joint state that would lead to that target. But if you are using RMP flow, you give it a target and it actually figures out like what are all of the moves in a row in order to get to that target, if possible. If you're not doing like any global optimization, just like locally optimal moves. So they're kind of mutually exclusive. Is global variables possible between OmniGraph nodes? So you can kind of force it. The docs for OmniGraph tells you to assume that different nodes are not necessarily all on the same machine, even, in which case that would kind of break down. But I believe that if you are running everything on one machine, you can kind of force it. It's been like a year since I've used OmniGraph or anything, so I don't remember exactly how, but I did manage to sort of make that work in a hacky way. But it's not supported behavior. Not right now. I think they have aspirations and dreams. Okay, so I'm going to end it here. That the loaded scenario template, what that would have given you is the load button with a run, and then I wouldn't have any of this like hacky kind of like run on every frame function. It would be more cleaner. Glad this was super helpful. Yeah, okay. So have a good day, everybody, and bye.